Hello friends, today we'll solve the signals and system problems of GATE 2025 electronics and communication paper. Okay, so this is the first question. Here we need to find out whether this system is a LTA or not. Okay, so this is a discrete time system with x1, xn and yn input and output, and h1n and h2n are the impulse response of LTA subsystem 1 and 2. So these are LTA and delta n is unit impulse, b is greater than 0. Okay, and h2n is not equal to 0, so overall system is. So we need to find out whether it is time invariant or not. So let's first find whether it is time invariant or not. So when we just delay the input, so first of all we need to find the expression of this thing. So this is basically, this part is xn convolution with h1n, and then this part will be xn convolution h1n plus beta del n, and then this part will be xn convolution h1n plus beta del n convolution with h2n. Okay, and so therefore the total will be, output expression will be xn, okay, convolution h1n plus beta del n times convolution h2n minus beta del n. Okay, so this will be convoluted with this thing and this thing, so this will be xn convolution h1n convolution h2n2 plus beta del n convolution h2n is h2n only, and then this is minus beta del n. So this is the final output expression. Okay, now for time invariant we will do the usual thing, that first we'll only delay the input. So this will give us x n minus n naught, okay, convolution h1n h2n and this same thing, because when we delay the input then we just delay this n minus n node in x term only. Okay, बाकी terms को ऐसा कैसे रखते हैं, then when we delay the output, then this time we will change all the n terms with n by n node. So y n minus n node is x n minus n node convolution h1 n minus n node convolution h2 n minus n node plus b h2 n minus n node minus b del. So clearly you can see these two are not equal, so therefore this thing is time variant. Okay, now for linearity we can do many things, like first of all you can see that there is a part, this thing is LTI because h1 h2 is LTI, but there is an extra time term added, so a time term and a constant is added, so this will be non-linear. Or you can see that the amplitude scaling, if we do, like suppose we keep this input as 4xn, then this will not give us the output as 4yn. Okay, because it will be only multiplied here only, so 4xn convolution will be the same, this term will not be multiplied by 4 throughout. So एक ये तरीका हो गया. Or what you can do is you can like see that for x1 input y1 will be x1 and convolution hn. I am taking this whole thing as hn. Okay, so hn plus bh2n and minus beta del n. Similarly for x2 input y2 will be x2n convolution hn plus beta h2 h2n this thing. Now when we add these two input, then output will be x1n convolution with the x2n, and then this thing entire input convolution with hn plus beta del n. So but when we add, तो दोनों को जब add करेंगे तो you will get x1n x2n convolution h2n plus 2 times, because this thing is coming 2 times now, so there will be 2 here, but when we give this input then there is no 2 here, so clearly superposition is failing here, so it is non-linear. So basically the system is non-linear and time variant. Okay. Second question is like basically on integration properties. It looks like a Fourier transform question, but it is on integration property only, that it is saying which consider a continuous time real valued signal ft where Fourier transform is standard formula, which one of the following is always true. So here you can see that f omega is like minus infinity to infinity f t e power minus j omega t dt. Now in all of them it has taken mod of it, so we'll take mod of it. So mod of it will give us mod here also. Okay, now you can see that if we take this mod inside, then what will happen, this part, if we take mod, then this will be greater than or equal to this part, because it will be equal to when this part is non-negative, and this part will be more if this part has some negative part also. तो mod लेंगे तो नेगेटिव पार्ट भी पॉजिटिव हो जाएगा, तो इसलिए ज़्यादा एरिया आएगा इस पार्ट में. ओके, so this is the main thing in this question. So now when we take mod of this, then we can take mod of this thing, and e की पावर माइनस जे ओमेगा टी जो होता है ये कॉम्प्लेक्स एक्सपोनेंशियल, इसका आपको पता है ये mod 1 होता है. So basically this thing is equal to minus ft dt. Okay, so finally the answer is f omega is less than equal to, this thing will always hold from mathematics. Okay, so this was second question, simple integration property. Third question is again theory question. It is on like let xn be a discrete time signal whose z transform is xz, so which of the following is always true. Okay, so here you can see that there's a discrete time Fourier transform of xn always exists. So we know that DTFT does not always exist. Okay, it exists only if ROC contain the unit circle. So this is clearly false statements. Region of convergence of xz contain neither pole nor zero. So ROC of xz does not contain pole, but it can contain zero. Okay, so this thing is also false. ROC can contain zero, no problem with that. DTFT exists if the region of convergence contain the unit circle. So yes, if ROC contain unit circle, then DTFT exists. So this part is true. If xn is a times delta n, where delta n is unit impulse, a is scalar, then region of convergence is entire z plane. So yes, if we take z transform, then it is alpha, so no pole, so ROC will be entire z plane. So this part is also true. So B and C are true. Okay, so this is easy question. This question is on like your continuous time Fourier series property of exponential signal. Okay, it is saying it that let ft be a periodic signal fundamental period t naught, and consider the signal yt is equal to, now the another signal is scaled version of t where alpha is greater than 1. Okay, so it is like alpha f of 2t. The Fourier expansion of ft and yt are given. Okay, this is ck e की power j 2 pi upon t naught kt and dk e की power j 2 pi t naught alpha kt. So which of the following is true? Ck is dk for all k. So whenever we do like whenever you do time scaling to a periodic signal, you just need to know simple property of Fourier series coefficient, that whenever you do time scaling to a periodic signal, then the values of exponential series Fourier series coefficient never change. Okay, so ck will be dk only for all k. So statement A is true, but the values will either, but these values will either expand or compress. Okay, so either they will come close or they will spread far away. Okay, so this part is true. And another thing is yt is periodic with fundamental period alpha. Another thing ck is, this part will be wrong. And on time period, if ft has a fundamental time period t naught, then f of 2t will have time period t naught by 2. Why? Because when it is 2t, so it will compress. So when it will compress, then time compression means expansion in frequency. Okay, so frequency will expand, so time period will be divided by 2. Okay, so here if it is 2t, so it will be t naught by 2. Okay, so yt is periodic with the fundamental period t naught by alpha. Okay, so the signal will basically, you can see it will come closer. So when it will come closer, so time period will also reduce by half. Okay, so this was the fourth problem. This problem is on sampling, and this is a difficult problem, lengthy and complicated, so we will ignore it. Okay, it's time consuming also. Okay, so these were the 4 questions. Thank you.